In the name of Almighty Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if anyone travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make this channel a grand success. We are a family, a partner. Please subscribe and share our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunities into success stories. These success stories can be monetized into value addition in the world by large. Thank you very much for your precious time. Okay, today I'm going to discuss my lecture number 24, oil and gas productions, exploration, production, upstream, midstream, refining, petrochemical, differentiated performance, enabling profit optimization process, lecture number 24. Before my lecture, I used to read a Quranic verse. Qala Rabbi shrah li sadri wa yassar li amri wa halal uqdatam min lisani yafqahu qawli Allahumma Rabbi zidni ilma. O my Lord, open my chest and ease my task for me, and loose an art from my tongue that they may understand my sin. Allahumma Rabbi zidni ilma. O Allah, advance me in my knowledge and true understanding. Please send me your input. I have provided my WhatsApp number and email address at the end of my slide. Thank you very much. Okay, oil and gas production. Introductions, facilities process, reservoir wellhead, upstream facilities, midstream facilities, refining facilities, petrochemicals, utility systems, unconventional, conventional resources, and environment effects. What is the ultimate goal? Shaping the clean and sustainable global energy delivery. So plan to deliver more than 300 lectures next couple of years. Okay. Oil and gas production, downstream facilities, lecture number 24, refining facilities, we are still discussing. Okay. Key takeaway points, lecture number 24, blending and distribution systems. Then we will reiterate different specification and advanced refining process. Okay, blending and distribution. After the refining process, the various frictions are stored in intermediate tanks, then blended into marketable product for loading onto the rail car trucks or ships and distribution to gas stations or industries as needed. Each product is blended to a specification of up to 25 parameters such as octane rating, energy content, and volatility and sulfur content. The task is to achieve the specification and not to exceed where applicable with the minimum amount of overspecs gave away. Blending quality is managed with infrared or chromatography type process analyzer. These can be determined the precise friction of sample by molecule type. The standard specification. Gasoline is therefore a standard from company to company in the individual market, ensuring compatibility with vehicle manufacturer requirements. Also, the terminal operator may be an independent, a third party, or run a co-distributions. Okay, so that a terminal in one region distributes for several companies based on the same product in the same tanks. Each company then seeks to differentiate its product by adding a small quantities of unique additive that are marketed to increase engine performance, lifetime, clean combustion, and so forth. These additives are added as the product is dispensed to trucks for delivery to that brand gasoline station. Okay. Our main task is to ensure the balance of incoming and outgoing product and consolidate with stored volumes. These have to be compensated for temperature, water content. Water may be absorbed from air, humidity, and released at low temperature as bottom slope in the tank, and vapor loss. Vapors are volatile organic compounds, VOC, from product is fixed or roof tanks, and when filling up a compartment in cars or vessels, the VOC loss can be significant for high volatility product like gasoline and must be recovered and or handled to reduce emissions and explosive hazard. The terminal management system track a batch of product received or dispensed as well as eventually received by gasoline stations, airports or other consumer and consolidate with stored volume. Each operation should be validated against orders, bills or loading positive identification of trucks, vessels or their operators. In many countries where this process is not well managed, loss of product due to theft and other factors can be as high as 15% or more in the distribution operations. Eventually, our main goal is to ensure that orders are met and stakeholders pay or get paid in the form of VAT, value added tax, product delivery charges. Okay, from my next slide, I will reiterate the advanced process refining and its products. And today we are going to wind up our refinery process lecture. Okay, frictional distillation. As we have discussed in my earlier lecture, today we are going to reiterate. First, LPG. Liquid petroleum gas has a carbon number of 1 to 5 and boiling point up to 20 degrees C. Most of the LPGs are propane and butane with a carbon number 3 to 4 and boiling points of -42 and -1 respectively. Typically, usage is domestic and camping, LPG vehicle and petrochemical feedstock. Next is the naphtha. Naphtha for full range naphtha is the friction with the boiling point between 30 degrees C to 200 C and a molecule is generally having a carbon number 5 to 12. The friction is typically 15 to 30% crude oil weight. It is used mainly as a feedstock of many other processes. Number 1, in the refinery for producing additive for high octane gasolines. Number 2, dilute for the transport of very heavy crude. Number 3, feedstock to the petrochemicals, olefins, feedstock for many other chemical, and number 5 as a solvent in cleaning. Okay, number next is gasoline. As the carbon numbers are mainly between 4 to 12 and a boiling points up to 120 degrees C, its main uses it as a fuel for internal combustion engine. Early on, these fractions could be sold directly as gasoline for cars, but today engines require more precise formulated fuel, so less than 20% of gasoline at the pump is the raw gasoline fractions. Additional sources are needed to meet the demand and additives are required to control such parameters as octane rating and volatility. Also, other sources such as bioethanol may be added up to 5%. Okay, now we'll discuss kerosene. Okay, kerosene has a main carbon numbers 10 to 16, boiling point 150 to 175. It has main uses as aviation, a fuel where the best known blend is a jet A1. Kerosene is also used for the lighting, paraffin, lamp and heating. Okay, then the diesel fuel. Diesel oil or petrodiesel is used for a diesel engine in cars, trucks, ships, trains and utility machines. It has a carbon numbers range of 8 to 21, mainly 1620, and is a friction that boils between 200 to 350 degrees Celsius. So there is also white and black oils. So the products of are called white oil and is friction are generally available from atmospheric distillation column. The remaining frictions are the black holes, which must be further separated by vacuum distillation due to temperature restriction of the heating rock root to no more than 370 to 380 degrees C. This allows the lighter frictions to boil off all the lower temperature than higher atmospheric distillation, avoiding overheating. Okay, so then we have here the lubricants. Okay, lubricants or minerals-based lubricants as a proposed synthetic lubricants form the basis of the lubricating wax and polishes. These are typical 90% raw materials with carbon number from 20 to 50 and frictions of boiling at 300 to 600 C. So the additives are used to control lubricant properties such as viscosity as well. Okay, fuel oil. Fuel oil is common terms encompass a wide range of fuels that also includes form of kerosene and diesel, as well as heavy fuel oil and bunker that is produced at the low end of the column before bitumen and coke residues. Fuel oil is graded on a scale of 1 to 6, where grade 1 and 2 similar to the kerosene and diesel. 3 is rarely used anymore. 4 to 6 are the heavy fuels, also called bunker A, B, C, where the B, C are very high viscosity at normal ambient temperature and requires a preheating to about 100 degrees C to 120 respectively before its flow enough to be used to the engine or bonus fuel. Oil a grade 4 does not require preheating and is sometimes mixed with off-spec products such as tank residue and interface liquid from multi-phase pipeline or with grade 2 fuel to achieve a low enough viscosity at ambient temperature. Fuel oil 6 is lowest grade. Its specification also allows 2% of water and 0.5% of mineral soils, and it consumes almost exclusively by large ships in international waters where the pollutants such as sulfur is less regulated. Okay, lastly the bitumen and the other residues like a coke and a tar, carbon numbers above 70 and boiling. Okay, so it's had a low sulfur. Coke can be used for the anodes, the mat industry, aluminum and steel. After processing, cleansing, the remainder is a problem fuels because of high sulfur content and even higher CO2 emissions, and then a coal a typical 50% higher. Bitumen is the form of asphalt. Boiling above 525 degrees C is used for the roofing and road paving. Asphalt, concrete, paved a material commonly composed of 5% asphalt and 95% stone, sand and gravel, etc. Okay, advanced refinery processes. As we discussed in my earlier lecture, we will reiterate these processes today again. First, atmospheric distillations. Atmospheric distillation is the frictional distillation unit, as we described earlier. Actual design, it is combined with vacuum distillation. Rock crude cannot be heated to more than 370 to 380 degrees C. It is often called the crude oil distillation unit, CDU. Okay, next is vacuum distillation unit, VDU. Further distill the black holes into fuel oil and residual bitumen and coke to avoid overheating the crude and to extract additional valuable product that could be upgraded. Okay, naphtha hydrotreater. Various sulfur compounds are present in the hydrocarbon mixtures, and if burnt with the other carbon will cause a sulfuric emission. The hydrotreater uses hydrogen to remove some of these compounds. Okay, then next is a catalytic reformer unit is used to convert the naphtha molecules C5 to C12 into higher octane reformate or reformer product. These are mixed with raw gasoline to achieve higher octane products. The process creates a more aromatic ring-formed hydrocarbons by dehydrocyclization or more complex hydrocarbon with double bonds or side groups by Dehydrogenations. These processes release hydrogen which is recovered and can be reused in hydrotreaters or hydrocracker. Okay, the distal hydrotreater unit desulfurized distills such as diesel after friction distillation in the same way the naphtha hydrotreater. Okay, fluid catalytic cracker FCC units upgrade heavier friction into lighter, more valuable product. Long chain molecules, higher carbon numbers are spilled into shorter molecules to achieve more of the high value of fuel components. A typical design uses reactor and regenerator, a fine powder post catalyst with zeolite, a silicate and alumina is fluidized in the hydrocarbon vapor, where a reaction takes place at 535 degrees Celsius and a 0.172 MPa megapascal pressures. The catalytic reaction takes place within a few seconds, after which the reformate and catalyst is separated in a cyclone. The spent catalyst then goes back to the regenerator that heats up to 750 degrees C at a 0.24 MPa megapascal pressure and release a few flue gases. The catalyst powder can then be reused. The reformates go to the distillation column for separation into frictions. Okay, next is the hydrocracker unit. Okay, what is a hydrocracker unit? Performs essentially the same function as the FCC when a more saturated hydrocarbons are desirable in the product. This means alkanes are carbon chains with single bonds, not double bonds, or cyclic rings like aromatics, or more complex molecules. For this, additional hydrogen is needed. The reaction takes place with hydrogen under a pressure over a catalyst. The relative market need for diesel, kerosene, and gasoline will influence the choices of FCC versus hydrocracker. In the US, with higher relative volume of gasoline, a more FCC capacity is needed, while in Europe and Asia, with high diesel consumptions, a more hydrocracker is used. Okay, waste breaking units upgrade heavy residual oils by a thermal cracking into a lower viscosity product that can be blended into lighter, more valuable product. Waste breaking is characterized by thermal severity, range from mild cracking at 425 degrees C to severe cracking at 500 degrees Celsius. Depending on the residual oil, as much as 15-20% lighter fraction like diesel, kero, and gasoline could be obtained. The residue is tar and coke. Okay, Merex unit treats LPG, kerosene, or jet fuel by oxidizing ethyls, mercaptans, or to organic disulfides. The purpose is to reduce a strong odors caused by thiol abrasions or mercaptan. Okay, next is a coking unit. Delayed coking, fluid coker, and flexi coker, like the waste breaking, uses a thermal cracking of very high residual oil into gasoline and a diesel fuel. The residue is a green coke and is a further process to fuel coke, or if too low in sulfur and contaminants, to avoid not a coke for the metallurgy industries. Alkylation unit produced high octane components for gasoline blending. The main use is to convert isobutene C4H10, but arrange a different than into N-butane to alkylates, mainly isooctane or isoheptane, by adding an alkyl group such as a propane or butane over a strong acid catalyst such as sulfuric and hydrofluoric acid. Deminerization is similar to alkylinations but uses a dimer group instead of an alkyl group. For example, butanes can be dimerized into isooctane, which may be hydrogenated from isooctane. Next, the isomerization unit convert linear molecules to higher octane branches. Molecules by rearranging the same atom arranged in a different way. For example, C4H10 and butane has carbon atoms in a chain, while isobutane has a center carbon with one hydrogen and a three CH3 groups attached. The isobutane and then be fed to the alkylation unit. Steam reforming produces, not the steam reformer, produces the hydrogen for the hydrotreater or hydrocracker. Typical is the steam methane reformer SMR, where the steam reacts with the methane at 425 degrees C with nickel catalyst to produce synthesis gas, which is a source for many different reactions. Okay, amine gas treater. Amine gas treaters or closed unit and tail gas treatment convert hydrogen sulfide from hydrosulfurization into elements of sulfur. Okay, the reactor runs at 1000 degrees C and 0.15 MPa megapascal pressure with three steps, one thermal and two catalytic to remove a yield, improve the yield. Using this process, a modern refinery can raise basic gasoline yield depending on a crude quality from 10 to 14% to around to 70. Thank you very much for your precious time. Conclusion. Okay, what we discussed today: blending and distributions, friction distillation. We have reiterated and products. Then we discussed advanced refinery processes, atmospheric vacuum distillation, naphtha, catalytic reformers, distilled hydrotreater, and hydrocracker. Okay. Next topic: petrochemicals. References are Qatar Petroleum, the Qatar Oil and Gas Development Corporations, World Energy Outlook 2013, US Geological Survey, US Department of Energy, Schellenberger's, Wikipedia, State Oil, North 6, Story of the Oil Peninsula, Air, Liquid Gas and Cycle, Natural Gas from the Wellhead to Burner Tip. Together, everyone achieve more. Please do not hesitate. Send me your feedback, comments at t.masood.dear@bath.edu, or you can also send me your input at WhatsApp. So I have provided my number. Please stay at home, stay safe, inspired, and blessed. Thank you very much for your precious time.